let's have our free fall sample number 1. A stone is thrown straight upward with a speed of 20 meters per second. It is caught on its way down at a point 5 meters above where it was thrown. How fast was it going when it was caught? And letter B, how long did the trip take? Now, let's first start our given. Our given here, we have 20 meters per second as our initial velocity. And what's the other given? We have 5 meters above it was thrown. So 5 meters above where it was thrown. Now, it will be useful for us if we're gonna draw first the problem. So say for example, this was the ball, and it has an initial velocity of 20 meters per second, and it was caught somewhere here. Okay, the ball was caught wherein it is 5 meters above where it was thrown. So we are asked here for letter A, how fast was it going when it was caught? The required for letter A is the final velocity. Let's go now to our equation. Since we are asked for VF, and our variable here we have VI, and we have the distance, the best useful equation that we're gonna use is equation number 3, wherein distance is equivalent to VF square minus VI square all over 2A. Since this is a free fall, we all know that the value of A is simply G, and that is negative 9.8 meter per second square. Let me replace this with G. And then substituting now our values, we need to find first the value of VF. And deriving for that formula, we have 2dg equals to VF square minus the VI square. And therefore, we have 2dg plus VI square, and that is now the value of the VF square. The root of both sides will have now 2dg plus VI. So our final equation would be VF is equals to square root of 2dg plus VI. Now, let's go now to our solution. Since VF is equals to square root of 2dg plus VI, plugging these values, we will have now square root of twice the distance, which is 5 meters above, and then we have here the gravity, which is negative 9.8 meter per second square, and then plus 20 meter per second square. Then you square it, and then we have here VF is around square root of 302 meter square over second square. And then therefore the value of VF is around positive negative 17 meter per second. Now, since the action is downward, we will take now the negative sign, which is negative 17 meter per second. So we have now our answer for letter A. Now let's have now the letter B question. How long did the trip take? Let me erase first this. Now for letter B, we are asked how long did the trip take? Now we are asked for time. Now the best equation that we need to use, let's try to analyze. We have our acceleration. Yes, we have our acceleration. We have our V final. So my V final is already computed, and that is negative 17 meter per second. And we also have the V initial, which is 20 meter per second. Take note that this one is 20 meter per second. That is positive, and it is going up. While the VF, which is negative 17 meter per second, is going down. So our acceleration is negative 9.8 meter per second square. So the best equation that we need to use in order for to have time, we have here, this is the equation. VF is equals to VI plus GT. Then we have to derive first for the time. We have VF minus VI equals T multiplied to G. Then dividing both sides by G, we could have the equation for time, which is VF minus VI over G. Let's go now to our solution. We have VF minus VI over G. Substituting these values, we have negative 17.4 meter per second minus the initial velocity, which is 20 meter per second, divided by negative 9.8 meter per second square. So let me try to press first my calculator. That is negative 37.4 meter per second divided by negative 9.8 meter per second square. We have 3.816. And then the unit is second. So we'll have our two significant figure. We need to round it off. So therefore we have 3.8 seconds. And that is our answer for letter B. Sample problem number 2 for free fall. A baseball is thrown straight upward on the moon with an initial speed of 35 meters per second. Compute for letter A, the maximum height reached by the ball, and letter B, the time taken to reach the height, and letter C, its velocity 30 seconds after it is thrown. And the last one would be when the ball's height is 100 meters. So, let's try first to identify all the given in our problem. First, we have 35 meters per second that is thrown upward on the moon. So therefore, that is positive 35 meters per second, and that is our initial velocity. Next, so we have to compute the maximum height reached by the ball. Therefore, the value for our G, gravity, so therefore we have 1.60 meter per second square. That would be the value of our G, and that is negative. So what is the required? Let's try to solve first for letter A. For letter A, our required here, we have the maximum height reached by the ball. So therefore, that is distance at its maximum height. What will be our equation? We have here the equation as vf square minus vi square divided by 2g, and that is the distance. Now, so solving for the problem, we could take note that the final velocity is 0 meter per second, because the moment that you throw it up, and when it will reach its maximum speed, here it is stopped. So meaning to say, the final velocity is 0. So from going up, then once it will change its direction at the maximum height, it will suddenly stop for a fraction of a second. We have here the vi square, and that's around negative and then 35 meter per second. Then you square it, divided by the value of twice the gravity of the moon, and that is negative 1.6 meter per second square. And upon pressing in calculator, we have here 382.81 meters. Or round it off to two significant figure, we have here 380 meters. That is our answer for letter A. For letter B, we are asked for the time taken to reach the height. So we have here the time taken to reach that maximum height. Our best equation, since we have the V final and the V initial, we have our V final, and that is 0 meter per second. We also have here the V initial, which is 35 meter per second, and we have the gravity, which is around at negative 1.60 meter per second square, and we are looking for time. So therefore, the best equation to be used is equation number 1, and we have Vf is equals to Vi plus Gt. And solving now for time, we have Vf minus Vi divided by G, and that will give us the time. So plugging in now into our equation, we have here the value of the Vf, which is 0 meter per second, minus the value of our initial velocity, which is 35 meter per second, divided by negative 1.60 meter per second square, and that will give us an answer of, let me press that in calculator, it's around 21.88. The unit is seconds, and rounding off the two significant figure, we have it 22 seconds. So this is our answer for letter B. Now, how about for letter C? Let me first erase these solutions. Okay, so let me again redraw my diagram. The ball, it has been thrown at around 35 meter per second. And somewhere here it will change its direction. Required for our letter C, what is velocity at 30 seconds after it has been thrown? Okay, so what's the best equation to be used? For letter C, the best equation to be used if you try to analyze a problem, let's try to analyze first what are the variables. We have the VF, and that is the unknown. We have 30 seconds as the time. We have the acceleration, which is negative 1.60 meter per second square. And then we also have the initial velocity, which is 35 meter per second. Therefore, the best equation to use is equation number 1. Vf is equals to Vi plus Gt. Since we're looking now for the final velocity, could simply directly substitute it to our variables. We have here the Vi, which is 35 meter per second. The value of G is around negative 1.60 meter per second square times the time square, which is 30 seconds. And that is, let me compute in my calculator. So we have here the Vf equals to 35 meter per second plus negative 1.60 meter per second square. And then we have the time, which is 30 seconds. So upon pressing it in my calculator, you can take note that the Vf, so upon pressing it in my calculator, the value of that would be negative 13 meter per second. So what does this mean? This means that the velocity is 13 meter per second, and that is downward after 30 seconds it has been thrown. This time let's solve for letter D, and we are asked for the time when the height is 100 meter above. Okay, so somewhere here we are asked for, so for example this is 100 meter, we are asked for the time. So let's have it now. So the best equation that we're going to use is try to identify first our given. We have the distance, which is 100 meter. The initial velocity we also have, which is positive 35 meter per second. We also have the G, which is negative 1.6 meter per second square. Now we could now try to compute, and the best equation for that is this one. So we have D is equals to VIT plus GT squared divided by 2. Now let's try to solve this. 100 meter, and then we have here the VI. The value of VI is positive 35 meter per second. We don't have the time, so times T plus the GT. The value of G is negative 1.60 meter per second square, and then the value of time, which is we don't know, but this time it is square, and then divided by 2. Let's continue now to solve the problem. We have 100 meter, equals to 35 meter per second times t minus 0.80 t square. Let's try to remove the units for us to see what could be our possible solution. Okay, so we can see that this one is a quadratic equation. Now let's try to rearrange it. We have 0.80 t square minus 35t plus 100 equals 0. So the best solution for this, for us to solve the value for t, is we'll use the quadratic equation. And the quadratic equation, remember that we have negative b, positive negative, square root of b squared minus 4ac all over 2a. Now let me erase first letter c. Okay, may I write this on this part? So we have here 0.80 t squared minus 35t and then plus 100 equals 0. So take note that this one will represent our A, this one will represent the B, and then this one will represent the C. So let me substitute it in my quadratic equation. We have here the value of t is equals to negative b, which is my negative 35, plus minus square root of b square, which is 35 negative, square minus 4a, which is 0.80, times the c, which is 100, divided by 2a, which is 0.8. So what would be our answer? Let me press first the calculator. And then we could have the two values for t, which is simply 35 plus 30.08 divided by 1.6, or t, which is 35 minus 30.08 divided by 1.6. So we could have now our two values, and the two values for that would be, so this time we have two values for time, and let me write it in my blue ink. So therefore the time would be, for the first one, we could have 41 seconds, and the other one, the time could be 3.1 seconds. Now let's try to see which one is the answer. The answer for letter D would be 3.1 seconds. Simply because when time is 3.1, the ball is 100 meter and ascending. And at 41 seconds, it is at the same height but descending. Let's have our sample problem number 3. A ballast bag is dropped from a balloon that is 300 meter above the ground and rising at 13 meter per second. For the bag, letter A, find the maximum height reached. Letter B, its position and velocity 5 seconds after it is released. And letter C, the time at which it hits the ground. Now, let me write first the given. The given is here that the balloon is, the initial velocity of balloon is 13 meter per second. So the value of g is negative 9.8 meter per second square. Later, after some time, the balloon will drop off the bag. So let's have our letter A. Find the maximum height reached. So what is the required here? So for letter A, the maximum height reached. And then let's try to analyze what will be the best formula that we're going to use. We have the initial velocity, which is 13 meter per second, and that is positive because simply the balloon is going up. And then after that, we also have the value, which is g, which is the negative 9.8 meter per second. Now take note, as the bag is being pulled up at the maximum height, the VF is 0 meter per second. So the bag will rise at the initial velocity, and then after that, when it will change its direction, before it will change the direction, that will be the maximum height. The final velocity for that is 0 meter per second. The best equation that we're gonna use is this. So we have here the Vf square minus Vi square all over 2g. Since the final velocity is 0, this already cancelled. And then we have the negative Vi square, so negative. And then the value for Vi, which is positive 13 meter per second. And then we square it. Then divided by 2 times negative 9.8 meter per second square. So let's press that first in the calculator. It's 13 squared divided by 2 times 9.8. And the answer for that is around 8.62 meter. So rounding off into two significant figures, we have 8.6 meter. Now, 8.6 meter, since the ballast bag is 300 above the ground, so that is still we need to add it up to 300 meter. Height would be 308.6 meter. This is the answer for letter A. And this time we have to find for letter B. We have to find the position and velocity after 5 seconds. And what's our given? Our given still the same. We have 13 meter per second as our initial velocity. The gravity would be negative 9.8 meter per second square, and of course we have 5 seconds. Now based on our given, we can identify that the best formula that we're going to use is equation number 2. We have here the time element as well as the initial velocity element and the g. So let's try it now. We have here d is equals to VIT plus GT square over 2. And then therefore we could have now the initial velocity, which is 13 meter per second, multiplied to time, which is 5 seconds, plus GT square. We have here negative 9.8 meter per second square, multiplied to time, which is 5 seconds square, and then divided by 2. Okay, so let's have now our calculation. Upon pressing my calculator, I could get negative 57.5 or negative 58 meter. Okay, now this means that still that that ballast bag is trapped from a balloon that is 300 meter above the ground and rising 13 meter per second. After 5 seconds, it will have a height of negative 58 meter. But the actual height that we're going to look is, remember that we have 300 meter above the ground. So meaning to say, I should subtract 300 meter minus 58 meter, and that is approximately 242 meter. And this is my answer for letter B. Now, for letter B, we are also asked for velocity after release. So, the best equation would be equation number 1, which is Vf, and then Vi plus Gt. And then calculating for that, that would result to 13 meter per second plus negative 9.8 meter per second square times 5 seconds, and that would result to the final velocity, which is negative 36 meter per second. This negative 36 meter per second, this denotes that it is 36 meter per second downward. So that is our final velocity for letter B, wherein we are asked for velocity 5 seconds after it is released. Now for letter C, we are asked for the time when it hits the ground. So take note that the total time here, so we have 300 meter. But this 300 meter will be represented as negative or as our displacement. Why negative 300? Because the balloon is dropped 300 meter above the ground, meaning to say the displacement is 300 meter and then going down. So that is negative 300 meter. So the best equation that we're going to use, we have this d is equals to VIT plus GT squared divided by 2. So substituting now, we have negative 300 meter, the VI, which is at 13 meter per second, multiplied to time, plus negative 9.8 meter per second, square, multiplied to time square, then divided by 2. Now, let's try to rearrange this equation and simplify this equation. We have negative 300. Let me remove first the unit. And then we have 13t minus 9.8 divided by 2. That is around 4.9 t square. So rearranging, we could have 4.9 t square minus 13t minus 300. And then in order for us to solve for t, we could apply our quadratic equation, which is x equals to negative b positive negative square root of b squared minus 4ac all over 2a. And then rewriting now our equation here, the 4.9, this will be our a, the negative 13, this would be our b, and the negative 300, that will be our c. And then therefore we could have now time is equals to negative b positive negative square root of b squared, which is negative 13 square, minus 4 times the a, which is 4.9, times the c, which is negative 300, divided by 2 times 4.9. And then let's solve now in our calculator. So this is by shortcut computation. So we have 13 plus negative 169 plus 5,880. Take note that we have here as negative, then minus negative, we could have the plus sign. Now the value for our t, we have 13 plus 77.78 divided by 9.8, and the other one would be, time would be 13 minus 77.78 divided by 9.8, and then this one has a negative value, so we don't consider it. On solving it in calculator, the value now is 9.26 seconds, or 9.3 seconds. So this is the final answer for letter C.